Welcome to our breakdown of the LabVIEW Snake game. In this video, we'll take you behind the scenes to explore how this game works, focusing on the key LabVIEW block diagrams that make it all happen. From snake movement to apple placement and collision detection, let's dive into the logic driving this classic game. At the core of the snake game is a continuous while loop. This loop runs the game logic frame by frame, handling player input, updating the snake's position, checking for collisions, and refreshing the game field. The loop only stops when the player either quits or the game ends. The game responds to player input using an event structure that listens for keyboard actions. The V key, or char property inside this structure, likely determines which key was pressed. So when you press an arrow key, the game captures that input and updates the direction variables, either moving the snake up, down, left, or right. Importantly, the logic prevents the snake from reversing directly into itself, ensuring smooth gameplay. Now let's talk about how the snake moves. The snake's head is updated every frame based on the current direction. This block diagram calculates the new position of the snake's head by adding the direction vector to its current position. Here, we ensure the snake cannot move backward by comparing the new direction to the old one. If the input direction is invalid, the game retains the previous direction. For example, if old direction Y is 1 or down, new direction Y must not be -1 or up. If the snake crosses the edge of the grid, it doesn't crash. Instead, the game implements a wrapping logic to teleport the snake to the opposite side. For example, if the snake moves past the top boundary, it reappears at the bottom and vice versa. This is managed by checking the position against the grid's dimensions and wrapping it around when necessary. The top box handles the snake's position on the y-axis, while the bottom section handles the snake's position on the x-axis. The next y or next x is the calculated next position of the snake in the y, or x-axis direction. Rows or columns are the total number of rows columns in the grid. The logic is as follows. The first comparison checks if next y is greater than or equal to the total number of rows. If true, it means the snake has gone below the bottom boundary. The second comparison checks if next y is less than 0. If true, it means the snake has gone above the top boundary. The results of these comparisons feed into a select function. If next y exceeds the bottom, the output is 0, wrapped to the top of the grid. If next y goes above the top, the output is rows -1, wrapped to the bottom of the grid. Otherwise, the value of next y remains unchanged. The corrected y position is passed to the output next y. The logic is the same for next x, just with the x-axis instead of y. Now let's look at how the apple appears on the grid. The game generates a random x and y position for the apple within the grid boundaries. However, it ensures the apple doesn't spawn on top of the snake's body by checking the grid for collisions, using the snake field in, which represents the current state of the grid and the snake's position. If the position is occupied, it generates a new random location until a valid spot is found. This ensures the apple always appears in a playable position, adding a new challenge for the snake to chase. Each time the snake eats an apple, the game updates the score. This is managed by increasing the snake's length and keeping track of the number of apples consumed. The score variable keeps track of each time the snake eats a food item. The game checks for collisions on every frame. If the snake's head intersects with its body or a wall, the game ends. This is checked by the wall check and hit yourself logic fields. This is a crucial part of the game loop to determine if the player loses. To summarize, the LabVIEW Snake game is a fantastic example of how every little aspect of a game holds such complex logic and rules in order for everything to work together smoothly, but can come together to create something fun. We hope you enjoyed this deep dive into the LabVIEW Snake game. Don't forget to like and share if you found this interesting and to subscribe for more content.